The global landscape of technology is undergoing a seismic shift. At the heart of this transformation lies the semiconductor industry, the cornerstone of modern electronics. China and the United States are locked in an intense competition for dominance in this critical sector. Semiconductors, the brains of everything from smartphones and laptops to advanced weaponry and artificial intelligence systems, have become a strategic asset. The stakes are high, with national security, economic prosperity, and technological supremacy hanging in the balance. China, once reliant on foreign chip imports, has embarked on an ambitious journey to achieve semiconductor self-sufficiency. This strategic move has sent ripples across the globe, challenging the established order and ushering in a new era of technological competition. The outcome of this race will have profound implications for the future of the global economy and the balance of power in the 21st century. In recent years, China has made remarkable strides in semiconductor research. This progress is not just a result of increased funding but also a testament to the nation's strategic focus on innovation and technological advancement. The nation's commitment to becoming a global leader in this field is evident in its staggering investment in research and development. Billions of dollars have been funneled into state-of-the-art facilities, cutting-edge equipment, and the recruitment of top-tier talent from around the world. From 2018 to 2023, China witnessed an unprecedented surge in semiconductor research output. This period marked a significant transformation in the global semiconductor landscape, driven by China's relentless pursuit of excellence. This surge is reflected in the sheer volume of scientific publications and patents. Chinese researchers have been prolific, contributing groundbreaking work that has pushed the boundaries of what is possible in semiconductor technology. Chinese researchers have rapidly increased their share of global publications in semiconductor-related fields. This achievement is not just about numbers, it signifies the growing influence and recognition of Chinese research on the global stage.
In 2018, China surpassed the United States to become the world's top publisher of scientific papers on semiconductors. This milestone was a clear indicator of China's rising prominence in the field. This trend has continued, with China consistently increasing its output and widening the gap with other nations. The country's research institutions and universities have become powerhouses of innovation, driving forward the global semiconductor agenda.
This surge in research activity is not merely about quantity, it is also about the quality and impact of the work being produced. Chinese researchers are not just publishing more papers, they are publishing better papers. The quality and impact of Chinese research have also seen a significant rise. Many of these publications are now being cited by researchers worldwide, indicating their importance and influence in the field. Chinese researchers are now at the forefront of several key areas in semiconductor science and technology. Their work is paving the way for new innovations and applications that could revolutionize industries and change the way we live and work. Collaboration has also been a key factor in China's research surge. By partnering with international scientists and participating in global conferences, Chinese researchers have been able to share knowledge, gain new insights, and push the boundaries of semiconductor technology even further. Looking ahead, China's commitment to semiconductor research shows no signs of slowing down. With continued investment and a focus on cutting-edge innovation, the nation is poised to remain a dominant force in the semiconductor industry for years to come. As China continues to break new ground and achieve new milestones, the global semiconductor landscape will undoubtedly be shaped by the contributions of its researchers. Their dedication and hard work are driving the future of technology, one breakthrough at a time. China's focus on semiconductor research is deeply intertwined with its strategic goal of achieving technological self-reliance. This ambition is not just about advancing technology but also about securing a future where China is not dependent on other nations for critical components. Semiconductors, the tiny chips that power everything from smartphones to advanced military systems, are at the heart of this mission. The Chinese government has made semiconductor independence a national priority, recognizing the critical role these tiny chips play in powering its economic growth and national security. This strategic focus is evident in the numerous policies and initiatives aimed at bolstering the domestic semiconductor industry. By reducing reliance on foreign technology, China aims to mitigate risks associated with geopolitical tensions and potential supply chain disruptions. The Made in China 2025 initiative, unveiled in 2015, laid out a roadmap for China to become a global manufacturing powerhouse in 10 core industries, with semiconductors identified as a key sector. This initiative underscores the importance of developing a robust and self-sufficient semiconductor industry. It aims to elevate China's manufacturing capabilities, ensuring that the country can produce high-tech components domestically and reduce its dependence on imports. This drive for self-sufficiency stems from several factors, including concerns about reliance on foreign suppliers, particularly in light of geopolitical tensions, and the potential for supply chain disruptions. The global semiconductor shortage has further highlighted the vulnerabilities of depending on external sources for critical technology. By building a resilient domestic supply chain, China aims to safeguard its technological advancements and economic stability. The US government's restrictions on selling advanced chips to Chinese companies like Huawei served as a wake-up call, highlighting the vulnerabilities of depending on foreign technology. These restrictions have accelerated China's efforts to achieve semiconductor self-reliance, prompting increased investment in research and development, as well as the establishment of new semiconductor manufacturing facilities. China's ambition is to build a complete domestic semiconductor supply chain, from chip design and manufacturing to packaging and testing. This comprehensive approach involves not only producing the chips, but also developing the necessary infrastructure and expertise to support the entire life cycle of semiconductor production. By doing so, China aims to become a global leader in semiconductor technology, capable of competing with established players in the industry. This involves nurturing homegrown companies, attracting top talent, and investing heavily in research and development. The Chinese government is providing substantial financial support and incentives to encourage innovation and growth within the domestic semiconductor industry. By fostering a vibrant ecosystem of semiconductor companies and research institutions, China is laying the groundwork for a future where it can achieve technological self-reliance and maintain its competitive edge on the global stage. Section 4. U.S. Response, Funding and Restrictions. The United States, long the global leader in semiconductor technology, has witnessed China's rise with growing concern. The U.S. government has responded with a two-pronged approach, increasing domestic research funding and implementing export controls to restrict China's access to advanced technologies.
The CHIPS and Science Act, signed into law in 2022, allocated billions of dollars for semiconductor research, development, and manufacturing in the United States. This landmark legislation aims to bolster America's competitiveness in the global semiconductor industry and reduce its reliance on foreign suppliers.
In addition to boosting domestic capabilities, the U.S. has imposed export controls on certain advanced semiconductor technologies, particularly those with potential military applications. These restrictions are intended to slow China's progress in developing cutting-edge chips used in artificial intelligence, supercomputing, and other strategic sectors. Section 5. Closing the technology gap. China's surge in semiconductor research has fueled its rapid technological advancements, allowing the country to close the gap with leading nations like the United States. Over the past decade, China has invested heavily in research and development, focusing on creating a robust semiconductor industry that can compete on a global scale. This strategic push has not only accelerated technological progress, but also positioned China as a formidable player in the tech world.
Chinese companies are now producing increasingly sophisticated chips, including those used in smartphones, data centers, and other high-tech applications. These advancements are a testament to the country's growing capabilities in semiconductor manufacturing. The production lines are becoming more efficient and the quality of the chips is improving, making them competitive with those produced by leading global manufacturers. This progress is evident in the performance of Chinese-made smartphones and other electronic devices, which are now on par with, if not superior to, their international counterparts. While China still lags behind in some areas, particularly in the most advanced chip-making technologies, its progress has been remarkable. The country has made significant strides in closing the technology gap, but there are still challenges to overcome. For instance, the production of the most advanced chips, which require cutting-edge technology and precision, remains a hurdle. However, the continuous improvements in older technologies and the gradual adoption of newer methods indicate a positive trend towards achieving technological parity with leading nations.
Experts point to the growing expertise of Chinese researchers and engineers, coupled with the government's unwavering support, as key factors behind this rapid advancement. The collaboration between academic institutions, private companies, and government bodies has created a fertile ground for innovation. Government policies and funding have been instrumental in driving research and development, providing the necessary resources and infrastructure to support the semiconductor industry. This synergy has enabled China to make significant progress in a relatively short period. China's vast domestic market also provides a significant advantage, offering a testing ground for new technologies and economies of scale that are difficult to replicate elsewhere. The sheer size of the market allows for extensive testing and iteration, leading to rapid improvements and refinements in technology. Additionally, the domestic demand for high-tech products drives continuous innovation and production, creating a self-sustaining cycle of growth and development in the semiconductor industry.
However, challenges remain. Despite the impressive progress, China faces significant obstacles in achieving complete self-sufficiency in semiconductor manufacturing. China still relies heavily on foreign equipment and materials for chip manufacturing, particularly for the most advanced nodes. This dependency poses a risk to the country's technological ambitions, as any disruption in the supply chain could hinder progress. The reliance on international machinery and expertise highlights the need for China to develop its own advanced manufacturing capabilities. The country is working to overcome these hurdles, but achieving complete self-sufficiency in the semiconductor industry is a long-term goal that will require sustained investment and innovation. Continuous efforts in research and development, coupled with strategic investments in infrastructure and talent, are essential for China to realize its ambitions. The journey towards self-sufficiency is challenging, but with persistent effort and collaboration, China is poised to become a leader in the global semiconductor industry.